Today we're diving into the world of remote control cars, specifically on the topic of rack steering. That's this kind of steering, and it's the mechanism that you find in most four-wheel cars. We will be discussing how to program this kind of steering mechanism and how to drive a car with it. I don't have a car with four wheels. Why? Because to properly drive a car with this mechanism, you need a differential, and there is no differential gear in the SPIKE Prime set. And an electronic differential is a different programming challenge. So for now, we're driving the rack steering mechanism with a single rear wheel for propulsion. In another video, I'm discussing how to do this with four wheels. There is an add-on for this model, 2 extra wheels with motors of their own. And in that other video, I'm discussing how to program the motors for this kind of steering with 2 rear wheel motors, because that requires some extra math there. For now, we'll keep it simple and just discuss the rack steering. You can download the building instructions for this car, and also it includes the single wheel and the 2-wheel model with the link in the description and with the link in the top right corner of the video. Now, to program the rack steering, let's start by creating a new program. Let's call it Hot Rod, and use a word blocks program. Then first we will want our steering motor to go to 0. My steering motor is F, and A and B are the propulsion motors. And once the let's just run this program to at least see this working. Okay, that seems to work. Now, what you can see is that the motor is in the 0 position, all right, but the wheels aren't, and that's because there is some gearing involved. So the black gear here, this one is straight, but because this one is straight, the tan gear here cannot be straight. So there's probably a 15-degree difference that we have to take into account. So let's see if we can make the motor come really to 0, or at least let's see if we can make the wheels center accurately. If you like this video, remember to hit the subscribe button. I really appreciate that. See if 15 does the job. Well, 15 looks much better. If we look at this motor position, this has the annoying property that it goes from 0 to 360 and it doesn't have negative numbers. So we're not going to use this position. We're going to use advanced motors and use the relative position, which is a number that can go negative. And once we've gone to our neutral position for the front wheels, let's keep track of that position with the relative position and have a nice 0 there. Then next we need a control loop, and what we will do in this control loop is calculate an error. So let's make a variable for that, and the error is the difference between the actual motor position and the desired motor position. So let's set the let's calculate this from the relative position and minus. So let's say our desired position is I don't know, 30 degrees, and the error is then, depending on where the motor is, the error is 0 when we're exactly at 30 degrees, and it's positive or negative when we're away from that. So what we can do now is start this steering motor at a factor relative to the error. So if we can see this, let's start with factor 1. So you can see that if the motor is beyond our desired position, let's say at 35, this one, the error will be 5, because 35 minus 30 is 5. And then we have to go back to 30. So we will multiply this by -1, and you can use -1.5 or -0.0 to change the speed with which the motor returns to our desired position. So let's try this program for a bit. Let's first move the motor somewhere here. Okay. And what we see now is that our program works. The motor goes to our position of 30. You can see that here. So the faint gray line is at 30 degrees, but our wheels moved in the opposite direction for less than 30 degrees. That's because, again, there is a gearing here, and the gearing is a 20-tooth gear and a 12-tooth gear. So now we will take the gearing into account to actually make the wheels move where we set the parameter. Let's say the gearing ratio, let's make a variable for that, and the big gear is 12 and the small gear, the big gear is 20 and the small gear is 12. We will see if that works by multiplying our desired position with the gear ratio. Now let's see if the motor actually moves to our desired 30 degrees. Aha! What happened is that, let's go back to my screen. What happened is that I was too fast. I thought I could input 2012 like this, but that doesn't work. It reads that as text, so we'll have to make it an actual division, 20 divided by 12, and then run the program. Good, that looks like it, except that we're turning left for a 30-degree turn, which is maybe the wrong way around. So let's not only make the gear ratio a fraction here, but also make the gear ratio a negative number, so that when we're turning 30 degrees, it actually turns 30 degrees to the right. Okay, so now this looks quite a lot like 30 degrees to the right, and but this is very static. So now let's see if we can make this interactive. To make this interactive, we will be using an other motor. So I'm going to plug in a third motor, a fourth motor actually, in the D port, and see if we can make our front wheels track this motor. Yeah, our motor shows up here. That's motor D, and let's center motor D2. And also set its relative position to 0. Now we have motor D, relative positions, okay. And now we will see if motor F can track our motor D. So then we will read our relative position, and instead of a static number, we will have the relative position of motor D as a target. And let's see if that works for us. Okay, let's see. Wow. So what we did is we created a feedback loop where the motor F tries to minimize the error between the position of motor D and its own position. This all goes really fast, so you almost don't see it moving, and motor F stops exactly at our desired position. Now, once we have this feedback loop mechanism, the next step is, of course, to make the car drive, and to this is a lot of fun. Yeah, if I would drive the car with a remote control wire like this, but it's even more fun if we can drive the car with a gamepad. So our next step is to connect the gamepad and input a value from a gamepad stick into our steering rack mechanism and program here, and use another gamepad stick to move forward and backward. To connect with the gamepad, we are using a chip here called LMS-ESP32. It's an external chip that has onboard Bluetooth and can connect to almost any gamepad. And I flashed it with a special firmware that that emulates a color sensor, but it's not a real color sensor, because instead of colors, it sends across the values of the sticks. But by emulating the color sensor, I can pick up the data from this chip into a regular WordBlocks program. This port E. Okay, port E, there you go. If you get this board out of the box, you probably need to flash it with a special firmware that emulates the light sensor. So I'm going to show you real quick how to do that. You can do it by simply plugging in a USB wire. I'm using this thing here because my Mac has USB-C. And then you can go to firmware.antonsmindstorms.com, and in this firmware use BluePad for SPIKE 3. In the future, there might be a universal firmware that's working for both Pybricks and SPIKE 3. For now, we opted for different firmwares because Pybricks treats sensors a little different than SPIKE 3. Since we're working on SPIKE 3 now, use this firmware, click connect. If you connected it, the board will show up here. I can connect and then install it. It will erase it, just click install, and you just wait a few seconds until the firmware is erased and we can write new firmware over it. Maybe you can see it in the background. We've been working hard to create different firmwares for this chip. It's got Python firmwares and it's got BluePad firmwares, which are specifically for gamepads. Good, installation complete. To pair the gamepad, at least the Xbox 360 gamepad, you press the pairing button here. It starts flashing quickly, and as soon as it detects this board, it will connect, and you can see now there is a solid blink, and now the Xbox gamepad is paired with this chip. It stays paired if you turn the robot on and off, so that's very comfortable. Next, I'm going to download a little template program to where it does the conversion of the light sensor data to a gamepad. So to find the library, you can go to my website, click SPIKE Prime tutorials, and then scroll down to where you find how to use a gamepad with SPIKE Prime word blocks. And somewhere here there is a BluePad SPIKE template file. So let's open this and download the raw file. It's into my downloads, and I can click it and open it. So once this one is open, I can copy paste blocks from this one to my actual program here. So what I'm going to do is copy my program or the my block here and copy it over. So I'm going to click it and then press Command C, and then here press Command V. That gives me the my block, and it also makes a my block show up here. Then we need to read the BluePad in our port. I think it was E. Let me see. And next we will have the variables here. The problem though is that these values, as you can see in the README here, they go from 0 to 255, and I think from -100 to +100 is more convenient. So I'm going to add some more conversion here to recalculate this one to go from -100 to +100. So let's then take that variable, or no, we can actually make another my block for this, which makes even more sense. So 2 minus plus 100, and we'll add an input, and it's going to be a number. Oh no, we can't add an output, doesn't work. I thought it was, sorry, I'm confused. So we will have to do this by hand for every value here. We will take the original value here, LX, subtract 127 from it. Then we will at least have a number from -127 to +127, but we want it to be 100 based, so we will divide this by 127 and then multiply it by 100. And now we will have a number between -100 and +100. Let's duplicate this a few times. And so the left stick in the Y direction, let's do right stick in the X direction. Change all of that. Good. And now by running this loop, this my block will call the BluePad and set these global variables, and we will be able to read the stick values on the gamepad. I like to have steering on my left stick, or LX, steering on my left stick horizontal, and propulsion power on my right stick vertical RY. So let's remove motor D here. We don't need motor D anymore. And let's use our brand new variables. And we will have to add an other operator here, because now our ly value goes from -100 to +100. But the steering wheels don't go that far. So let's make this make it like 45% of the original value. Left stick. Oh no, it was going to be the horizontal left stick. So that's LX. Good. So that's 45% of 100. This is going to be this is going to generate a number of -45 degrees to +45 degrees, and it will be a nice steering wheel. So let's see if all of this really works, and run the program. Oh yeah, that doesn't work because of one very nasty bug in the SPIKE Prime software. When you copy a my block with variables, the program just crashes. So it's better to actually copy all of this into the downloaded program. So let's do that. Let's copy this into this one, and then because of this horrible bug, we have to delete this, delete that, delete, and recreate the error variable. So let's call it error2, and let's call it gear ratio 2. Otherwise this doesn't work. This is really shitty. So let's make this gear ratio 2, let's make this error 2, and let's make this error 2. Then this main loop can go, and let's replace it with our new loop. Let's make sure that our gear ratio is set, that we have our error here, and our left stick X, oops, dude, okay, and our left stick X there. Let's see if this works. Okay, what we see now is that the values from the stick come across, but there is a problem with the oh yeah, code. Of course, this one shouldn't have been error, but it should have been our new gear ratio. Yeah, that happened. Good. This does something. It still has a bug. Let me see. Of course. What we didn't copy was the extra code here to make the variables go to 0. So let's see if we can copy this back over to our other program without it breaking. I'm very curious if this will work. Yes, so copying the variables back here works, that because probably originally these variables came from this file, and so copying it back doesn't break the SPIKE program, but it's still a nasty bug, and if you don't know what's going on, this can be really confusing. So let's switch my camera view to the car here, and you can see that the front wheels follow the front wheels follow the stick quite nicely, and that's just steering, of course. And the next thing we're going to do is program forward and backward. Now that we have this program where we have calculated the error between where we want to be and where the motor really is, and we calculate our wished position from the original or from the position of the left stick. X is horizontal, I is vertical, from the LX, and use the 45% of value of that, because then it goes between -45 and +45. And then our next thing that we should do is start moving the propulsion motor, which is A, at a speed of RY. RY, where are you? Oh, I'll just use LY, right mouse button, and change it in RY. Let's see if that works. Okay, so this still works. That doesn't work. I think we made a mistake. Let's see. Okay, this is the mistake. For me, that's always confusing, switching between Pybricks and SPIKE Prime, because setting the speed is never good enough in SPIKE. Pybricks this works. In SPIKE you also have to start the motor and then set the speed. So let's run this new program again. Okay, and now we can drive. The direction is reversed, however, because pulling it back makes the car go backward, and pulling it forward makes the car go forward. So we'll have to fix that. Okay, let's stop the program just to be sure. And multiply RY by -1, effectively reversing the direction. Let's see if this works better. Good. Nice. So now we're driving forward, backward. We can steer left, we can steer right. It's time to take this car for a ride on the floor. Are you ready to build your own remote controlled car? Head over to antonsmindstorms.com to find the building instructions and all of the programming code. I hope you enjoy playing with it. See you in the next video. Bye bye!